Hi, my LeetCode fellows. Today we will try to solve one more task, and let's see what it is. Is a task maximum count of positive integer and negative integer numbers. Given an array, numbers sorted in non-decreasing order. So, increasing or equal. Return the maximum between the number of positive integers and the number of negative integers. Return between the number of positive. In other words, if the number of positive integers in nums is pos and the number of negative integers is neg, then return the maximum of pos and neg. 0 is neither positive or negative. Okay, I believe that we should use a binary search here to speed up this solution. And this is how we should find index of last negative and the first positive integers. And after that, we can calculate it easily. Result. Alright, now sorted. It didn't say that all the numbers in an array are integers, but in examples we see that there are integers. Okay, let's try. Left equals to 0, right equals to nums length -1. After that, actually we need two binary searches for example, for first 0 and for last 0. What can we do here? What can we do here? If we are using binary search, could these two searches help each other? Well, I think that yes, but how? How? We can do this thing. We can look for first 0 for the last negative integer. But while we are observing it, we will try to find the last index of non-positive integer that would be presented, and after that we can start from it. This is how we can avoid extra iterations. Let's try. Last non-positive integer index is 0, for example. Then we're starting our binary search. While left less than right. If numbers left what kind of condition should we have? If numbers left right plus 1, if numbers left well, no, we're looking for not for one number. And binary search, yes, it should work. Let's say that we want to make early exit in case of if numbers first number is bigger than 0, then we should return numbers length. In case of all positive, then we should have all negative. If numbers length equals to 0 and return 0. Numbers at -1 less than 0, then we also return a length. Now we know that there are 3 categories of numbers: positive, negative, or 0. And we need to find the index of the edge between them. How will we do it? If we're using binary search, would it work just as we expect? Yes, why not? We're looking for first zero number, for example. First index, we're looking at the index of last negative number, while left not equal to right minus first negative or first positive, because we may not have negative numbers. Okay, we're looking for, let's say, for the index of first zero for this, and it could be the first number in our array. So middle would be right minus left divided by 2 mod floor. If middle we should understand if the for example this and this middle would be 0, 1, 2, 3, 4, 5, 6. 6 minus 0 divided by 3, 3 divided by 2, 3, 0, 1, 2, 3. This number. How can we say should we move right or left? Okay, let's imagine that this is this number, minus 1. If this number is less than 0, minus 1 for example, then we should move left to this index. Middle index. Middle value is nums middle index. Nums at middle index. If middle value less than 0, then we're moving left. Left equals to middle value. Of first 0. If it is less than 0. But we may not have 0 at all. Middle value and middle next value plus 1. If middle value less than 0 and middle next value bigger or equal to 0, last negative index, then last value negative index would be middle index. Break. Middle value. Middle next value. Return nums. If it is equal to 0, then we will return 0, in other case return 1. If middle value less than 0 and next value bigger or equal to 0. Yep. There can be other case where we don't have negative number. My floor, right minus left divided by 2 minus 1. First we will have 3, and okay, yeah, it can work. 2, 3, 5, 4, first, yes. What if middle index equals to 0? So if middle value equals to 0, and middle index equals to 0, then we will set last negative index as -1. In other case, if middle value less than 0, then we will move left, else we will move right. How will it work in this case? For example, length is 6, 0 not equal to 5, middle index would be 6 minus 0 divided by 2, 3, minus 1, 2. 0, 1, 2. Middle value would be -1. Middle next value would be 0. Middle value less than 0, and middle next value bigger or equal to 0. Yes, last negative index would be 2. Fair enough. Here, 5, 0 is not equal to 4. Middle index would be 5 minus 0 divided by 2, which is 2.5. My floor 2 minus 1, index would be 1. This number. Middle index, middle value -1, middle next value minus 1, not satisfied, not satisfied, middle value less than 0, left would be middle index. Left would be here, 1. After that, 5 minus 1, 4 divided by 2. Oh, we will not move after that. We should do this. Four divided by 2. We should make sure that we're moving left or right. How to make it sure? Left minus right minus left divided by 2. We should not decrement here. Right minus left. Okay, let's start from the beginning. Right minus left divided by 2 is 3, which is 0. Next one is also 0. If middle value less than 0, then we're moving left to 3, but it's not. Then we're moving right. Next iteration, right would be 3, left would be 0. 3 minus 0 would be 3 minus 0 would be 3 divided by 2, 1, floor 1. So we're getting this number, minus 2. We're comparing it, and it's less than 0, so left would be 1, right would be 3. After that, 2 divided by 2. Middle index would be 1. Right is 3, left is 1. Right minus left, 3 minus 1 is 2, divided by 2 would be 1. Something wrong with this logic. Right minus left divided by 2 plus left. So here we will have 3 minus 1, 1 divided by 2. One plus 1, 2. Yes, let's start from the beginning. 6. 6 minus 0 divided by 2. 3 plus 0 would be 3. Okay, guys, let's continue. I have distracted a little bit, but now I'm here again. Here we can simplify this expression and let's check it again. 6 divided by 2 would be 3. 3 not satisfied. This condition is not met. Middle value less than 0, not met. It would be here, right, would be moved to 3. After that, 0 plus 3 divided by 2, 1.51 would be this one, minus 2 minus 1, less than 0, left would be 1. After that, 1 plus 3 would be 4, divided by 2 middle index 2, and here we meet this condition. Last negative index would be 2. Yes, which is right. Here we would have 2.52, 1, 2, minus 1, 1. Here we initially meet this condition, and last negative index would be 2. And here we're meeting this condition. Yep. I would also add as if nums 0 equals to 0 and nums at minus 1 equals to 0, then we will return 0. Okay, now we have last negative index, which could be minus 1, as we know. Yep, and we were writing TypeScript. We don't want to forget this. Minus 1 or number. Okay, what's next? We're having last negative index, last non-positive integer index. Last non-positive integer index. If middle value is bigger than, well, actually here this is a like extra optimization. I would remove it. First positive if. Okay, now we know that we have if last negative index is not equal to minus 1, then we have two options. We have option where we only have 0 from the right. So if the last number is 0, for example, this case. -2, -1, 0, 0, 0, 0, 0. Then what do we have? Then we need just to return last negative index plus 1. In other case, we know that we also have positive numbers. And we need to find index of last 0. Index of first positive number left equals to but we can also have -1. Max left negative index and 0, and right is again the right side of expression. And we have next loop. Middle value. If middle value is less or equal to 0 and middle next value is bigger than 0, then index of first positive integer would be middle index plus 1. In other case, if middle value, no, we cannot have this case this time. If middle value is bigger than 0, for example this, then we should move right. In other case, we're moving left to middle index. Yes. Let's just imagine this case. Left would be last negative index, which would be 2. Right would be 6. 6 plus 2, 8. Middle index 4. 1, 2, 3, 4. Next value would be 1. Is equal to 0 and it's bigger than 0. And index of first positive number would be middle index plus 1. So 4 plus 1 would be, which would be 5. It would work. Let's try this. last negative index would be 0, 1, 2, 3, 1, 2. Right would be 5. 5 minus 2, 5 plus 2, 7, 3.53, middle index 3, 0, 1, 2, 3. Next value is 2. Middle value is bigger than 0. We're moving right to middle index. Right would be 3, left would be 2. After that, 5 divided by 2 would be 2.5, middle index 2. Next, middle next value 1. And we're satisfying this condition. Index of first positive number would be 3. Yes, it should work. And now, what we have? Return math max. Zero. Oh no, we just can get last negative index plus 1 and numbers length minus index of first positive number. So for example 6 minus 0, 1, 2, 3, 4, 5 minus 5, 1 plus 1. Okay, it's time to check all the solution. It is pretty big. I think we will be able to simplify it a little bit, but let's just make it work right now. It would be number if number's length equals to 0, return 0. If number's length equals to 1, then return 1. If it is not equal to 0, yep. If all positive or all negative, then return length. If all nulls, then return 0. So last negative index would be left middle index, middle value, middle next value, middle index, middle, yes, if it is middle index, middle value is equals to 0 and middle index equals to 0. We should make it simpler. Equals to -1. And if numbers 0 bigger or equal to 0, only then we will start this loop. If left, right -1, maybe we can use just while true. I don't need this condition anymore. And here we're looking for the edge between negative number, because we know that there is a negative number, and we know that there is 0 or positive number. Yeah. After that, one more early exit. If there are no negative numbers, else. Or, wait, if there are negative numbers, okay, then next loop. We're looking for the first right index. Middle index value, if middle value is do we know that there are positive numbers to the right? We can use something like this. If there are no positive numbers, okay, we already did it. So we know that there are positive numbers to the right side. And we're looking for it. Yes. If middle value bigger than 0, then we're moving right. If not, we're moving left. And after that, we return everything. Well, it should work. Index of first positive number. I don't know. Here can be a TypeScript error because we didn't assign the initial value, but I'm not sure. It depends on TypeScript settings. But let's just try what we got. Looks like it should work, but property length does not exist. Length 69. Length. Yep. Expected 3. Output 1. Okay, let's see what we have. Last negative index. Index of first positive integer. We have early exit. Not this one. Yep. This is the mistake. My mistake. And here I had one more mistake. Index of first positive number is 3. 0, 1, 2, 3. Yes. Output is 4. Number's length is 5. Oh, number's length is 6. 6 minus 3 plus 1 would be 4. Here we should not increment it. Okay, this case, index of first positive number is right, 0, 1, 2, 3, 4, 5, but last negative index is wrong. Something wrong is here. Numbers are 0 less or equal to, well, let me remember what I meant here. Less than 0. Yeah. Here I have wrong condition. Last negative index is 2. Index of first positive number is undefined. Last negative index is 2. Yes. Index of first positive number is undefined for some reason. Middle value, middle next value. Let's just check what kind of conditions do we have here. Middle index is 3. Zero, 1, 2, 3, y3, left, right. Left 2, yes. 0, 1, 2. Right 5, 3, 4, 5, yes. Left index, middle index would be 5 plus 2 divided by 2, 3.5. Middle index would be 3. Yeah, but we're looking for positive 1, which means that we should and we're comparing these numbers. Middle value, middle next value. It doesn't satisfy this condition. If middle value is bigger than 0, then right would be middle index, right would be 3, which is yes, which is okay. But after that, this condition is not working. Yes. While true. Let's just try. Yes, now it works. And I believe that here we also need to change this condition, because the problem is just the same. Okay, let's try to submit it. I will remove all locks. And let's see what will happen. Yes, beats 100% of solutions. Good result. Okay, a little bit later I will go back. We will look at the complexity, at my mistakes, and at other options. Okay, let's see what we could do different way. Whoop. Something happened with my web camera. Oh, sorry. Yeah. Okay, I will repair it later. Okay, what do we have? We have a pretty optimal algorithm. Before moving through the mistakes, I would prefer to see the other solutions. My solution is pretty big. I believe there could be simpler ones. For example, this. Okay, we just have two binary searches. Pretty easy. Nothing special. We need JavaScript. Super easy beginners. And what do we have here? Really? Yes, this is ON. Bad complexity. This is also linear complexity. As well. And that one. Wow. No, I don't like these solutions. Well, this time I like my own solution much more than solutions of the others. Let's look at my mistakes, just to remember and to make it, not to make it next time. Here I used a sign operator instead of comparison operator, which is yes, which is a mistake. Here everything is okay. Here everything is also okay. Here I had wrong condition. While true. Yes, I just forgot about it. Here I knew that I have I had extra condition, and that was a mistake because it broke the logic. All the other things are okay. And here we also have kind of small optimization. Here we don't have TypeScript error. Left. Right. Here's a mistake with while condition, and that's it. Okay, I think that can be the final solution, and we should calculate the complexity, the final complexity, what it would be. Space would be O1, because we only have variables that contain numbers, and we don't have a lot of them, just a few. And time complexity would be O first binary search log n, and second binary search would be O log n as well. Which would be O log n. I'm not sure if I've written it correctly. O log n, no, everything is okay. So yeah, that's it. This is my final solution. Great. Thank you very much, guys. Nice task. I should remember also how to optimally create binary search next time, because I had problems with these conditions, with this formula. Next time I should remember how it works, just not to make this mistake. The key points are this formula, while true, and the final condition that will break the loop. Okay, thank you very much.